For this project, I did the animation at like 2:30 in the morning yesterday, so the animation's going to be pretty bad. Um, so this is Theo and Trenton's chemistry project by Theo and Trenton. So for our project, we decided that we want to do something cool, but we needed to figure out what we thought was cool, and explosions are pretty cool, so we decided to do explosions. First, we came upon ANFO, or ammonium nitrate fuel oil, which they used to blow up mountains. But then we figured that out, that it was very expensive and also illegal, so we had to switch our things up and think outside the box. And we came up with potassium nitrate, which is smaller, so we decided to do it because bigger doesn't always equal better. And it's normally used in combination with sugar and not gasoline, so we had to do some research on the internet about the correct ratio from gasoline to potassium nitrate, but we couldn't find anything, which means we would have to experiment with it with ourselves. The second thing we had to do was find a place to do it at, and we decided on a large concrete area in Hamilton, which is right next to some very, very dry grass that was ready to be lit on fire by an explosion that we didn't know how big would be. So everything was looking absolutely phenomenal. So next we went to Penny Hardware because we waited till 3 days before the assignment was due, and we bought some very normal things that people buy, like something that explodes, a fire hydrant, and campfire fuel. And then we checked out and we went to the fire station because none of our parents were okay with us doing this without any approval from the fire station, so we needed to get their thumbs up. And we went to them and we were like, we're a bunch of teenagers trying to do a chemistry experiment. We have no idea what we're doing and we want to blow something up. Can we do it? And they said no. So we talked a little bit afterwards, and then they asked if we had done any research, and we said yes, we did. And for some reason, I had made actually a paper on it. I have no idea why I did it, and it was really stupid. But then he asked to see it, and he was like, wait, this isn't that dumb. And so he called his brother, who was an industrial chemist, and we did a really, really bad job at explaining what we were doing. So he was like, absolutely not. So we then found out that actually it's not illegal for us to do an explosion there, but if we did end up sparking something or causing a fire to start, even if it was for a tenth of a second, even if there was a fire spark from the explosion initially, even if it didn't go anywhere, then it would be illegal. But we didn't know if it would spark, so now we were left with the decision. We could either listen to what the people who knew what they were talking about told us, or we could just go blow something up because we thought it was cool. And I can guarantee you couldn't guess which one we did, because we actually did the right thing, partially because we could all totally imagine the headlines of a newspaper saying a bunch of dumb teenagers burned everybody's houses down, even though the fire department told them not to do it. Because I need to narrate, I'm just going to talk about the video while the video is happening. I don't even remember what happens in the video because actually I made it like 5 minutes ago. I just don't remember anything that happens in it. So we got all the materials, but we ended up taking like 2 hours before we actually started with it. So the first thing we did was delicately measure out the potassium nitrate and just decided that a number was a good number when it showed up on the scale.
Theo, I told you not to open that.
We were just hanging around trying to make sure that we weren't going to blow anything up, and I guess Tristan was having a really good time with that, looking at himself. Okay, it's gone. Then we added in this potassium nitrate, and I don't know why I decided to show 2 different angles of it, but I did, because it's really exciting.
Touch me again.
And then, oh yeah, that happened too. And we added in the tequila. Once again, 2 different angles because it's really exciting. And then we lit it on fire with a blowtorch because it takes a while to light on fire, because I think the water needs to evaporate before you can actually start lighting it on fire. And then the fire actually started going. Yeah, look at it. It's pretty cool. It was turning a bit purple, but unfortunately none of the cameras were really able to pick it up. So actually I guess we decided to put marshmallows over it.
Orange,
we didn't eat any.
as you can see, guys, the experiment. And you can see the sides. and it's
I really
bubbling.
shouldn't be holding this over, but the big part is already gone, right?
It's getting more orange on the side, and you can still see it bubbling, but at a smaller amount. It looks like it's evaporating.
And Tristan gave us a brilliant explanation of what was going on. So after the first experiment, we decided to try it with campfire fuel instead of the tequila to see what would happen, because we're chemists and we experiment with stuff that we don't know what will happen in our own backyards. So, I didn't know how the blowtorch worked, so I was just like putting gas in there without it lit. So we had to go back, and we eventually figured it out. And all it needed was actually a single light, and it was just became a fire, I guess. And then it just went on as a fire for a while, and nothing really happened. I think Trenton threw in a marshmallow. Oh yeah, we had chicken nuggets. Trenton threw in a marshmallow at the end. It didn't get very purple, because the gasoline didn't really react well with the potassium nitrate. So we added in some alcohol and set it on fire again. And you could see the purple right there. And yeah, then he threw in the marshmallow.
Hey guys, welcome back to the vlog. Today, Theo's dad told us not to do something, but Theo eventually talked back enough to get him to do it, so...
Yeah, so I convinced my dad to let us mix the campfire fuel and the alcohol together to see what would happen then, because once again, we're chemists and we experiment with stuff that we don't know what will happen in our own backyard. So then we lit it, and once again it lit immediately because of the campfire fuel. And then he threw in a marshmallow. Very satisfying sound. I don't really know what happened there. And then it kind of just died out after a little bit more purple flame. And then it kind of started crystallizing a little bit, as you can see, which is a physical change. And we've already done 2 chemical changes, which was the lighting the campfire fuel and lighting the alcohol on fire. But we do a third one where we mix sugar, potassium nitrate, and alcohol and mix it together with a marshmallow and try to light it on fire. And then we measured that, but it doesn't show, definitely. Then we tried for like 20 minutes to light it on fire, and it just didn't want to light. We blowtorched it and everything, and it just didn't really work. But there was still a chemical reaction. So then we decided to do the physical changes, which was the potassium nitrate and water, and we just mixed it around and dissolved it, and then started boiling, and then we left to go to my room and do normal things while we waited. That is a photo you guys are going to remember. Hold on, wait, one more. And while we were doing very mature things, the pot kind of started to overflow, and we didn't realize because we were doing mature things in my room. Get in there, Johnny. Get in there. And it just kept exploding, but it crystallized on the outside. That looks pretty cool, actually. But it made a really big mess that I had to clean up afterwards. And then we poured it in this thing, and Tristan had a great time. And we waited for it to crystallize. If you look closely, you can actually see it crystallizing, but I'm too lazy to edit it, so just look close, I guess. And then we tried it again, but we ended up making something that, well, it looks like something else, but, you know, it didn't really work out because we added too much, and that was the pot afterwards. It looks a little cool. It also took a long time to clean up, so not so cool. And these are the requirements, and actually it's 11:22 right now, not 10. So this is a classification matter. These are some pure things that you can find in my house. Gold is in the jewelry, silver is in the jewelry, the copper is in wiring, aluminum is in kitchen foil, iron is in iron cookware, carbon is in the air, tin and in pencils, carbons in pencils. Tin is in cans for food storage sometimes. Lead is in my fishing gear. Nickel is in some coins. Zinc is in batteries. Silicon is, I don't even include silicon, did I? Oh, never mind. I don't have any silicon in my house. And we have water, and table salt, sugar and vinegar, and baking soda as compounds, and those are a bunch of solutions. Is that what it was? No, those are heterogeneous mixtures, actually, but there are so many that I can't explain each one, see? So I have so many, and those are a bunch of, not compounds, those are a bunch of common solutions that you find in the house, and again, there are so many of them that I could not take the time. I don't want to waste your time, so I won't be explaining all of them. Next, we have to describe potassium nitrate. I'm just going to be saying as it comes on the screen because I have absolutely no memory of what any of this was. Its equation is KNO3. First, we're looking at potassium, which is atomic number is 19. Its chemical identity is alkali metals. The atomic structure is Ar4s1. The nucleus of the atom is 19 protons and 20 neutrons in the most common isotope. Protons and neutrons are 19 and 20. The valence electrons are 1. The chemical properties of the element are highly reactive with water. The family group is the same as what I said. The average atomic mass and blah, 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 blah. Oh my god, this is so much. You can read it, you know, you're a good reader. You can read all of what I just put on the screen. And the chemical formula is KNO3. It decomposes upon heating to produce nitrogen dioxide and oxygen. It's generally safe, but if you eat a lot of it, it's toxic. So don't eat a lot of it. See, that was really clear understanding of the topic, Mr. Foster. So we should get all those points. And yeah, that's our project.